All right, chapter 17 of Solomon's 12th edition discusses carboxylic acids and the derivatives. These functional groups, including carboxylic acid, when carbon is double bond with an oxygen at the same time, this carbon is also single bond with an OH group. And when the OH is substituted with a halogen, and could be fluorine, chlorine, bromine, or iodine, the functional group is referred to as the acid halide. Okay, acid fluoride, chloride, bromide, iodide. Substituting the halogen or an OH group with a acyl-loxy group, and we get the acid anhydride. The anhydride can be considered as two molecules of carboxylic acid after removing a molecule of water and condense into the anhydride. And substituting the hydrogen on the carboxylic acid with an alkyl group and an ester functional group is over here, and substituting the alkoxy group and with an amine group, and we get the amide. Okay, here nitrogen could bond to hydrogens or alkyl groups and to give you primary, secondary amide. Okay, and another acid derivative is called nitrile. When carbon is triple bond with nitrogen, this is essentially a nitrogen analog of carboxylic acid, and these are the nitriles. Okay, so this chapter we're going to discuss physical properties, naming, and preparation, chemical properties, and spectroscopy property of these functional groups. Let's start with the simplest carboxylic acid and look at some of the typical bond length and bond angles and so on. So this is a formic acid, and with a one carbon which adopt an sp2 hybrid. Therefore, the bond angle is close to be a sp2 bond angle, 125 degree, and the carbon is double bond with an oxygen with a 1.202 Armstrong bond length, and this carbon also is single bond with an oxygen with a 1.343 Armstrong of bond length. And the oxygen over here has a bond angle, the carbon, oxygen, hydrogen bond angle of 106 degrees C, a very characteristic tetrahedral bond angle. And this particular conformation is in equilibrium with one of its conformer when you rotate this carbon-oxygen bond, and you can get this conformer. And the more extended conformation is typically the predominant conformation. Deprotonate the formic acid generates the corresponding conjugate base, and that's referred to as the formate. Okay, ATE is the suffix for many of the anions. Okay, once the formic acid is deprotonated to formate, the carbon-oxygen bond becomes identical in the bond length, 1.27 Armstrong, shorter than 1.343 for the typical CO single bond, and longer than 1.202 for the typical carbon-oxygen double bond. Indicates that the molecule, well, more accurately, the anion, is a resonance hybrid between the two conformations. And so the resonance hybrid essentially have the identical carbon-oxygen bond, same bond length, and same bond strength. Some other interesting property associated to carboxylic acid, including that carboxylic acid tend to have very high boiling point. And in comparison of acetic acid along with propanol and propanol, right? Carboxylic acid, alcohol, and aldehyde functional group. We can see the boiling point increase when the polarity of the molecule increase from bottom to top. And for the case of alcohol and carboxylic acid, and the intermolecular forces also include the hydrogen bond. Therefore, carboxylic acid and alcohol typically have very high boiling point. Okay, carboxylic acid, in fact, tend to, especially for smaller molecule carboxylic acid, tend to exist in this dimer form because of the very strong hydrogen bonding. And because of that, carboxylic acid also tend to dissolve in water pretty well. When you have a carboxylic acid contains 4 carbon or less, the corresponding acids are typically miscible with water. Okay, and for the rest of the lecture period, I have 5 handouts associated to naming of carboxylic acid and derivatives. So I'd like you to watch those videos to get yourself familiarized with carboxylic acid and derivatives.